Hey, good morning, guys. So we are going to start looking at differentiation today. So differentiation is just essentially talking about a rate of change. So when we talk about the rate of change, we are talking about what you usually calculate the gradient to be, okay? So it just says the rate of change of y with respect to x. So when I'm talking about the gradient with a straight line, I am talking about if this is 2, that means that every x I move, I will then have a rate of change of 2 in the y-axis. That's all it means by rate of change. It's essentially what you already know. They're just using a different way to say it to you. They also talk about speed, acceleration, but we will cover that later. But if you did just want to look at it, so say this is a distance time graph, then that would be distance over time, which equals speed, which is your gradient there. Or if you have speed over time just equals acceleration. Okay, so you should be aware of these two already. If you are, that's fine. If you're not, yay. But that's all you need to know. But for a straight line graph, obviously, so if I was looking at the left-hand side of that screen that says the gradient function, it does tell you if I had the graph 3x plus 2, then obviously the gradient will just be 3, okay? But what would I do if I start having curves? So in terms of what I would do if I start having curves is I would have to draw a tangent for each and every point at that curve just to find the gradient at that point. So in terms of this is y equals x squared. This table shows you the gradient at each of the points. So some of you may have figured out that the gradient is always double whatever x is. So if I was to talk about that gradient, I would just say it's 2x. Okay, hopefully that makes sense. So it's just double whatever it is. So if x was 10, I would expect the gradient to be 20. So just a nice simple example. Okay, but for differentiation, obviously we don't just keep drawing the graphs and drawing loads of tangents. We do have an equation for it. So at IGCSE level, all you need to know is this equation right here. So if y is ax to the power of n, then the differential would be, the first differential would be a times n times x, but I just drop the power of x. So you bring the power down, and then the power just gets dropped by 1. Okay, so some of you might look at this and say, where does this come from? So essentially, just remember when we were saying a change of y over change in x, that's a delta. If some of you heard me talk about it, it is a delta. Smaller case delta would be this. So this is for a big change. This is for a very tiny, tiny change. And so when we talk about the change of y over the change in x, we are talking about at that exact point. So whereas this, you choose 2 different points and you find the gradient, this you are choosing at that point what the gradient is at that point. So that's all where this comes from. Okay? So it's nothing too complicated. It's just using what you already know and just putting different letters in, that's all. Okay, so from your functions, you should also be aware that f can sometimes be written as a function of x. The input is x, the output is the function of x. That's exactly what y is. The input is x, the output is whatever y is. But when I'm writing the first differential for this, then you just add an apostrophe. So I'll be like, that's my function, that is the first differential of this function. Okay, so I would expect if you are talking about f of x, then you would be expected to write f apostrophe x just to show that that's the first differential of this. And then if you have a y, you're expected to write it this way. Okay, so if I have this, I'm not expecting to write dy over x. If I have this, I'm not expecting you to write that. So it's just something to think about. I think most people are kind of aware that quite a lot of people do use this terminology, and I've had plenty of people, instead of writing f of x, just write y of x and then just put dy dx. So don't worry too much about that. That's just one of those technical things. Once you're in the habit, you'll be fine. Okay, but anyway, we need to use this rule to find out those answers. Okay, so if I have y equals x to the power of 5, then I'm just like I've said here, I'm going to drop that power. I don't have a number here, so if a was a number here, it would be 1, so it stays as 1. That power comes down, so it's 5 5x, and then this power drops by 1. So 5 take away 1 makes it 5x to the power of 4. And I've written it like that, and it shouldn't be written like that. I'm so sorry. dy over dx is 5x to the power of 4. Okay? This is why you use a pencil. And I'm okay, because I have a whiteboard. But please make some notes about this in your actual books, not just on a whiteboard. That would be great. Thank you. So, next one. F of x. And now they're using the f of x. It's still exactly the same thing they're talking about, so don't let them confuse you. X to the power of a half. So my first differential would then be bring the power down, so half would come down, and then I have a half, take away 1, which is a negative half. Okay, for the next one we have y is 2x to the power of 6. So dy over dx, 6 comes down, it then becomes, I'll write it a bit long term as well, sorry. So I've got 2 times 6, and then multiply that by x. That becomes 5. So the 2 times 6 is 12, x to the power of 5. Okay, next one, I've got x over 4. We don't really want to do this, and we don't really want fractions. We just want everything on one line in this fashion. So first of all, I'm just going to simplify it, so it becomes 1 over x cubed. But then using my, you will use index laws in this. Using my negative index law, that then becomes this, because I know that a to the power of minus n is 1 over a to the n. So I'm literally just using that law and applying it here, because once I have it in this format, it's very easy to do. So then I would just bring the minus 3 down, x to the power of negative 4. Okay. Last but not least, we got y equals the square root x to the power of 6. Square root would just be a power of a half. So all I need to do is simplify that. 6 times a half is 3. So that means dy over dx equals 3x squared. So once you simplify it, it becomes so easy to do. So what I am going to ask you guys to do is see if you can answer these questions. I've given you one of the answers already. Okay, I'm not worried about that answer. If you can get to that answer, you're fine. You just need to make sure you can find out that missing square, because I'm not going to go back and do another box right now. So see if you can get to that final answer, but see if you can do those. Can you just make sure that you do actually pause the video and try them out? Thank you. Okay, so those are your answers. So if you simplified all of them, it should have been nice and easy. The one that you may have found a little tricky was with 4, where you basically have a come down, so it will be a times a, and then x to the power of a take away 1. So that would just become a squared. So rather than a, you would have put a squared. Okay, what would I do if I have 3 different terms? You can do exactly the same thing, I just have to do it separately. Okay, so I've got 4x plus 3, so dy over dx would then become 2x. This would then become 4. Okay, this one is the new one. So imagine if I have a graph and it's x and y, and I'm drawing y equals 3. That's what that graph looks like. What is the gradient of that line? Hopefully, you said 0. It is actually 0, so it would become 2x plus 4 plus 0. Because I don't need the 0 here, that would just be my number. So anytime you see a constant and it doesn't have an x term or anything else connected to it, when you differentiate, that just disappears and it just becomes 0. So when you have terms like that, just make sure you make it into 0. The only thing you would have just to expand on this is you might have y equals, say, x plus 1 squared. Okay, I can't do this because they're not all separate terms, so the first thing I would have to do is to expand the brackets. And then once I have that, then I can say, well, the differential is 2x plus 2, and then I would just ignore that. Okay, that would be the way that it expands. So this is going to be like exercise 2 or exercise 2 star in the book. So I'm just going to assign you exercises from the book because it's the best place to go in terms of IGCSE, because this is a relatively new thing that was added to the GCSE. So the best place to go would be that. Otherwise, if you start looking at other questions on the internet, it might delve into A-level topics, and you don't need to worry too much about the A-level topics right now. Okay, so just to go through a wordy example. You can then start applying this to questions that you may already have. It says, find f of x equals 4x squared, take away ax plus 3. Find the gradient at this point. Then it tells you to find the coordinates of the point where the gradient is 8. And then it tells you to find the gradient where the curve meets another line. Okay, so although it's given you a lot of words, it's not actually that difficult to go through. So I always write down whatever the function is because it's much easier for me just to see whatever it is in front of my face rather than looking over there. Plus, if I ever have to refer back to it, I would always see that function there. So first of all, they are asking me to find the gradient at that point. So I'm just going to find the gradient first, then worry about that point in a little bit. So the gradient for this point will then be, so the 2 comes down, 4 times 2 is 8. So that's 8x, take away 8. 8 to the power of 1, if you take away a power, x to the power of 0 is just 1. So that would just be 8 times 1, which is just 8. Okay, and then this just disappears. Now, checking what they're asking me to do, it says at that point where equals half and 0. So I've only been given a reference for x here, so all I need to do is look at the x value in there. So the x value they've given me is a half. So when I am talking about the first differential when x equals a half, that's all this means. It just means that's my first differential when x equals a half. That's all that means. So 8 times a half is 4. 4 take away 8 is negative 4. That would be the gradient at that point. Okay? Super easy, I know. B, it says find the coordinates of the point on the graph where the gradient is 8. So I've already found this out, but they're telling me when it equals 8. So I'm saying when this point equals 8. What is x at this point? Well, I've got an equation. I can solve it. So 8x equals 16. X then equals 2. So I need to find the coordinate of when x equals 2. So I know, sorry, let's refer to the terminology they are using. So just to pop it back into this original equation, I'm going to say what is that value when x equals 2? So it will be 4 times 2 squared, take away 8 times 2 plus 3. Okay, 4 times 4 is 16. 8 times 2 is 16 plus 3. So get rid of those 2 and it becomes 3. So the coordinate would be 2, 3 because x equals 2 and y at this point equals 3. Okay? Okay, you guys can pause if you need to do this because I'm about to rub it out because I don't have enough space for C. Okay, then for C, it tells me find the gradient of y when at the point, where the curve meets this line. So that's your simultaneous equations with one linear and one non-linear. So I already know what this equation is. So I'm going to say 4x squared take away 8x plus 3, and I want it to equal that 4x take away 5. Okay, so I want to move everything on one side so then I can solve it using quadratic means. Otherwise it could be factorizing, or it could be by the equation, or it could be completing the square, whichever one suits you at the end of the day. So we will have 4x squared take away 12x plus 8 equals 0. I want to make this a little bit easier for myself to solve, so I'm just going to factorize by 4. So then I've got x squared take away 3x plus 2 equals 0. I can then say, well, this is take away 2, this is take away 1. At this point, this 4, I don't really need this 4. I could pop it back in and say 4x take away 8 into this, or I could say 4x take away 4. and then it would make the x's be equivalent. But I don't really need it right now, so I'm just going to get rid of it because it's not really doing anything. So this is when x equals 2, this is when x equals 1. So find the gradient at this point where the curve meets this. Oh, okay, so I've got my x points. I've also, because it's just telling me to find the gradient, it's not telling me to find the coordinates, so don't really need to know the y at these points. But I do already know ax take away 8 is my first differential, so I can find the gradient from there. I need to know what it is when x equals 2, so that is 16 take away 8, which is 8. I also need to know for when it equals 1, so that would be 8 take away 8, which is 0. There you go, I found my 2 coordinates at those 2 points. Hopefully that makes sense. So I would like you to try, you've already done this one, haven't you? Yes? I would like you to try this example by yourself, so probably just pause, try it out, and then I'll just show you the answer in a tiny bit. Okay, so there's the answer. Just found the gradient when x was equal to 1. You then just need to find the coordinates when the gradient's 5. So just find out what x is, input x into the original equation. That will give you that coordinate. If you did it in decimals rather than fractions, that's fine, but fractions are acceptable. And fractions also, if you're without a calculator, it's much easier to do 9 over 2 squared than it is to do 4.5 squared, but it's just my personal opinion. And then obviously you just equate using simultaneous equations. It's exactly the same as what you've done before. Okay, so the next thing you need to look at is finding the equations of the tangents. I will also show you the normals, but tangents is usually more common. So I am kind of going to introduce you to a different way of writing equations. So you can use y equals mx plus c, and I will show the working for y equals mx plus c on here. But you also need to be aware that we do have that equation over there as well. So some of you might already be familiar with change in y over change in x, so you guys already know about that. But you may also know this formula. So if I have a set of coordinates, I can just use that. Okay, so all they've done in order to write that equation is instead of writing y2 and x2, because it's referring to the same point, rather than referring to the point, they're just going to refer to the actual variable. So all I'm doing is just, it's exactly the same equation, but I'm just referring to the variable because I'm saying as long as these two are connected, this formula will stay valid for the entire equation. But rather than putting it in this form, all they do is just bring the x out there. So mx is x take away x1, and that is equal to y take away y1, which is exactly all they're talking about. So if someone gives you a coordinate, they might give you a coordinate of, say, I don't know, 1, 2. Then where it says x1 and y1, that is where you would insert these two. So the x, the y, and the m obviously is a constant because it's a constant, but the x and the y would remain as variables. Does that make sense? Okay, so that's just a different way of thinking about it. So they are talking about doing it here. So when you are trying to find an equation, you can use either method. So for those people that want to use this equation, it is over there. This is more A-level knowledge. So if you just want to do GCSE and you're a bit like, no, A-level, don't do that yet. Then obviously you can just stick with the y equals mx plus c and not worry about it. For those people that just want to try their hand at it, just to make sure they're used to it, you will also see a benefit of it when we go into the normals. Okay, normal just being a perpendicular line. When you talk about, say, tangent, normal will always be perpendicular. It just means it's perpendicular to whatever the point on this curve is, that's all. Okay, so I know, loads of lovely words, and they're all things that you could understand if they just spoke about it, but all they do is just like giving everyone words. Okay, so we've got this. I need to find the equation of the tangent to that curve when x equals 3. So in order to find that equation, I'm going to work through on this one, and then we'll also just check to see how you would do it with that equation. So I first need to find out what the differential is. So to find this, I just need to find the differential. So the differential to that curve would then be dy over dx, which is 2x, because it says x squared, so I know the dy over dx is just going to be 2x. But it's telling me when x equals 3, dy over dx equals 6. Okay, so in this equation, I've got y equals 6x plus c. But because they've told me about x equals 3, that means when x equals 3, y equals 3 squared, so y equals 9. So I now have these two values, and I've also got the gradient. So the way to find out c is just to insert those three values into this equation, and then you can find out what c is. So I'm saying y equals 9, this would be 6 times 3 plus c. This would be 18, that's 9. Okay, so c equals negative 9, so y equals 6x, take away 9. Okay? Hopefully that made sense. Not anything too much to worry about right there. In this one, they kind of go through the same thing. They go through the gradient. They'll say when the gradient is x equal to 3 and y value when x equals 3. Okay, the only difference, obviously, to this one, so that's the same because we've already done it, that's the same because we've already done it, and that is the same because we've already done it here. The only difference is you would then get this equation. If you simplify it out, it will become this, but that's still an equation, so it's actually valid. You can keep that as an equation. So you don't have to simplify it, and if you did have to find the line that was perpendicular, you would then just only change one thing there, whereas you would have to work out something else here. You only have to change one thing in there. So I'll show you in the next one. Okay, so check that. Why didn't I check that? Doesn't matter. So the normal to the curve is a line perpendicular to the tangent. I've already told you that. And it says find the equation of the normal to this curve when x equals 3. So they're still talking about the same point. I know I can still use the 3 and the 9. That's perfectly fine. If I was using this formula, then I keep the x the same as it is already. And then all I have to do to the actual gradient is just find the negative reciprocal. Okay. For this one, I can kind of have the same equation, but I just need to change it up a bit. So instead of having this, I would then have y equals negative 1 over 6x plus c. I would then insert the 3 and the 9 into this as well. So then for y, I would put, well, that's 9, and this is minus 3 over 6 plus c. Then to find out c, that would obviously be 9.5. which some of you might leave like that, or you might put it into like fractions, decimals, whichever, which would then give me y equals negative 1 over 6x plus 9.5, or 9.5, whichever way you want to talk about it, doesn't really matter. Okay, so if I did it via the y equals mx plus c, I just have this working. If I choose this method, then obviously all I have to do is change that gradient. So it's entirely up to you. If you are thinking about A-level maths, then you might just want to look at that and go, that's okay. Or you might want to wait. So entirely up to you. You can go for either which method. Whichever method you feel most comfortable with, that's the method you should use. At the end of the day, it's only your GCSEs right now. So this is perfectly fine. If you are kind of looking at those higher level things, then you might just want to start looking at these because it can help save you a little bit of time during your wonderful exams. Okay, so the next part you need to look at is stationary point. Stationary point is essentially just whenever the actual gradient is 0. That's all a stationary point is. Or if you are looking at a curve, it's just whatever the turning points are. So if you look down here, these 4 graphs, well, they're essentially just 2 graphs. It's just a positive and a negative version of each graph. That's all it is. All you need to do is recognize what's a maximum point, what's a minimum point. So a maximum point is just where you get this kind of thing, and a minimum point is just where you get that, because that's the maximum, that's the minimum. It's one of those times where you can just go, that was so obvious, because it is. Okay, so you've got those, and they're asking you to be able to recognize cubic functions as well. So all you need to do, you don't have to know how to sketch them or what the actual points of interception are or anything else that is more A-level kind of work or further maths work. All they're asking you to do right now is just to be able to recognize the actual shape of the curve. That way, if they ask for a maximum, you know which one is the maximum, which one is the minimum, okay? So maximum obviously would just be that way, minimum would just be this way. But when we are recognizing curves, if I have a positive value x squared, I will always have a curve like this. If I have a negative value x squared, you just switch it around, it just reflects. Right? If I have a positive value x cubed, then it will look like this. If I have a negative value x cubed, then it's going to look like that. Hopefully that makes sense, right? That's all it is. So all you're doing is just making sure you look at it. And the number of turning points will be obvious because of this power that you see right here. So you know when you're differentiating with the gradients, this kind of, if I have y equals x squared, then the differential will be 2x. And you'll see this has a power of 1, so I'm only expecting 1 turning point. If I differentiate this, it's going to have a power of 2, so I expect 2 turning points, 1, 2. That's all you need to know from this kind of page. We will, the next page is going to show you about finding like maximum and minimum points, which is fine. But all you need to know is these 4 shapes, essentially, and then maximum, minimum, which should be super easy. Okay, so in terms of a question and incorporating what you already know, we have a question over there where it says find the turning points of the curve and classify their nature. So it goes through all of this. It's just essentially giving you different methods. So we'll just run through the answer in a nice, easy way, and then you can just do that. So find the turning points. So turning points means I need to find the differential. Take away 12x plus 1, right? So differential of each of these, you should have been used to these by now, so that will become 6x squared. This becomes 6x. This is 12. That just doesn't exist anymore. I need to find the turning points on this, so it's when it equals 0. So turning points is when this equals 0. So now this equals this, but I also want it when it equals this. So now I can just equate them to each other. So I've got 6x squared, take away 6x, take away 12 equals 0. I don't really need all of this. I can make it easier for myself by taking this factor of 6 out. Okay, and then it's quite easy to factorize this. So I've got x take away 2, x plus 1 equals 0. Don't really care about that. 6 right now. So just need to find this. So it's when x equals 2, when x equals negative 1. So when x equals 2, y equals negative 19. When x equals negative 1, y equals 8. So did they actually tell you to find the coordinates? Find the turning points. Okay, because they're actually asking you for finding the turning points, I would, better safe than sorry, write them down as coordinates. Okay, that way you found the turning points. So I usually underline stuff because it draws people's eyes to the actual answer as well. So if you can draw people's eyes to the answers, then they'll look at them and then they'll go, oh, okay, there's the answer, that's fine. And then they look at your method and be like, oh, okay, I understood how they got there. Okay, so we've got 219, 1, 8. So I just need to know the nature of these turning points. From up here, I can see this is a positive cubic, meaning I'm expecting this type of graph. So when I'm expecting this type of graph, you can literally just go which one belongs there, which one belongs here. So this is a negative 1, that's a 2. So this would be my negative 1, 8. And this 2, because it's further along on the x-axis, this would be my 2, negative 19. So when I look at this graph, and I've put the points on there as well, don't need to draw it out, I've just put the points on there to help myself. I know that this one is obviously a maximum then. and this is a minimum. Okay, so all you need to do is start going through this exercise on your online textbook as well, and that should help you out. So obviously it's page 387 if you can see it there. Okay, so the last part of differentiation talks about the motion of a particle. So when they're talking about the motion of a particle, this just refers back to the speed, distance, time, and then where you're also talking about the acceleration as well. So say if I said f of x talks about your distance, I would then say, well, the first differential talks about the speed, or in this case, why did I put sped? Speed, and then the second differential would be your acceleration. And why does that look wrong? I don't know how to spell, although it's literally on there and I spell it right. Okay, acceleration, whichever. Okay, so acceleration is your second differential. So the way they kind of refer to it is they're saying that you're differentiating speed. So that just means you're differentiating again. That's all that means, okay? So you just, once you have a differentiated term, you then differentiate again. So if I was to, I don't know, make up something, let's say 3x cubed plus 2x squared plus 3, because I can't bother. So say if this was f of x, then the speed would then be 9x squared plus 4x, and then you just cancel that out. And then the acceleration would be the second differential, which would then be 18x plus 4. Does that make sense? Okay, so that all they're trying to do is trying to get you to find, so this speed or velocity, sorry, because we actually have a positive and a negative in the x direction, they are talking about velocity rather than speed, because speed would just say, oh, they were driving 40 miles per hour going to work, they drove 40 miles per hour going home. So that's just a speed. Whereas if I was talking about velocity, I would say, say home is your 0 and school was like the end distance, then you would say they drove 40 miles per hour, positive 40 miles per hour away from the home towards school, but then it would be negative 40 miles per hour when they are going back home. Okay, so I think you guys have already covered this in science, but you should be a-okay with velocity. Velocity just means they've got a reference point, which just means 0, and then it's positive or negative in regards to that reference point. Okay, but it is essentially just talking about the second differential, so you just have to differentiate again. So rather than telling you to do ds, so they're using s for displacement or the distance, so rather than saying ds over dt, you would then use the speed or velocity, which would be the dv over dt. Rather than talking about it being the second differential, they're literally just differentiating again. Okay, so hopefully that makes sense. And with particle of motion, they're just putting in real life examples. So you saw the bike previously, and then you can see the cliff here. Okay, so it's saying a pebble is thrown at the maximum height, the velocity is 0, because obviously if you're throwing a pebble, the highest point is when the velocity stops. So it's just literally for that tiny moment of time, it is just basically hanging in midair. That will be your maximum point. So when we're talking about maximums, that is where your first differential equals 0. So let's run through the question. Okay, don't need that for the moment. So even if I just look at that question up there where it says a pebble is thrown vertically such that its height above the top of the cliff after t is given. So they are saying s equals 10t take away 5t squared. Find the maximum height reached by the pebble. At the maximum height, the velocity is so on and so forth. Oh, okay, that's quite a nice easy one. At maximum height. Okay, so the velocity is 0. So we have s is take away 5t squared. So in order to find v, we've got ds over dt. So got to differentiate that. But rather than in respect to x, we're doing it in respect to t now, which is time. Okay, so it's exactly the same because when we're drawing a graph, that's x, that's y, but in this case, we're going to have that's t, that's s. Okay, so just going across in respect to t. So this will be 10, take away 10t. Okay, that's going to be my velocity. And then it says at maximum height, the velocity is 0. So when 10 take away 10t equals 0, because that's my maximum, when it reaches that maximum up there, it will be 0, so v equals 0 at this maximum point. So we've got 10 equals 10t, t then equals 1. So all I now need to do is find out what the height is, because they're talking about a vertical throw. I just need to find the vertical here, not towards the camera. So I need to find out what the actual vertical height was. So I'm going to put for s up here, 10t take away 5t squared. I'm now just going to substitute t, so 10 times 1 is 10, take away 5 times 1 squared, which is just 5. So that equals 5. Okay, so then that was 5 meters. Because I believe they were talking about meters above a cliff. Yes, they talk about meters. Does that make sense? In regard to... just going to look on this side anyway. So in regards to, say, some of the ones they are doing in question 1, so you're kind of doing the same thing I've already given you examples for, but I'll just run through question number 1 just to get you through it. So you've got 1, it says displacement s of a particle after t seconds from a fixed point is given by s equals 10t squared take away 30t plus 1. Okay, so in order to find out v, that means I'm going to do ds by dt, which is just differentiating this. So that's 20t take away 30. Okay, and then, so this is part A. Then they're talking about acceleration. So as I said, you're literally just differentiating it again, which is the second differential. So otherwise you can just say it's dv by dt, or you could kind of say it's a second differential from s. Your choice entirely. So this is just 20 and that just cancels off. Okay, so the acceleration is just 20. And they're just asking for, this would be meters per second, this would be meters per second squared. Okay, awesome. Okay, so I'm basically going to say just make sure you refer to the book and do a selection of the questions from each of those exercises just to cover the differentiation aspect. So once you've done that, obviously, if you have any questions, email me, give me a photo of what you've already done. We'll try and see what we need to correct, just tweak it a little bit just to make sure you are there. Let me know how it goes, okay? So hopefully that should all be good. May you enjoy the rest of your day and stay safe and stay awesome.